Okay, this is going to be a tutorial on how to use um, functions with multiple inputs, or how to create functions with multiple inputs, in fact, an arbitrary amount of inputs. So to show this, I'm going to do an example. I'm just going to define A here as 1, 1, so that I don't have to keep defining it later. Now I'm going to use con, which is convolution of two vectors. So I'll do A with A. And then of course we'll give you 1, 2, 1. But if you try to convolve A with A with A, that won't work. You need to do something like this. But we're going to make a function that can do all of this in one argument. It can basically do this all at once. So I already have a new function opened. Go back to there. Call it conv-m, convolution multiple. Input arguments, put var arg in. Var arg in allows you to have an arbitrary amount of input vectors. For output, we'll just call it x. Now we're not going to worry about comments for now. So the first thing we want to do is that if we only have one input argument, we want the function to output that input argument. So we'll just put x equals var arg in 1. This just means that if there's only one input argument, then the output is going to be that input argument itself. Var arg in uses curly brackets syntax. Now what we want to do is that if there's more than one argument, so if nargin is greater than 1, then we want the output to be convolution of each of the inputs. So how do we do that? Well, we want x to be the convolution of what it previously was, so x with var arg in. But this obviously isn't going to work because not yet, because we need to add some number here. And we also need to add a for loop because we need to do it for every input. So we'll call it n equals from 2 up to nargin. Oops, nargin. Tab this over. So we want this to be var arg in n. Now we'll end each of these. So basically what this program does now is that in this line, if there's only one input argument, then the output is that input argument. For this series in the code, if the input arguments is greater than 1, then going through all the input arguments from number 2 up to the last one, the output is the convolution of what it previously was with the current input argument. So we'll save this. Go back to our command window. And now if we do conv AA, we'll of course get the same result. Conv m AA should return the same thing. Now let's try conv m of AAA, which should output the same thing as conv A, conv AA. And of course, you can extend this up to however many inputs you like. So this is a quick example of how to use functions of an arbitrary amount of inputs. Thanks for watching.